Good morning, friends. I feel immense pleasure to be here for my course, Aircraft Systems. Today, I am going to take a topic, a case study on aircraft fire protection system. We know that the aircraft is full of fuel, oil, and so many other burning material inside the aircraft. And also we can see that in engine, if you see a very high temperature, and there the fuel is also entering in the engine. So it is very difficult task to protect the fuel from that high temperature zone. You can see that the engine is also on the wings, and there the 80% to 90% the fuel of the aircraft is on the wing. So your aircraft is just touching your wings are touching your engine, and there is the high temperature zone is there. Still the fire is not taking place. So we should understand that what type of method the engineers are using to protect the fire from such type of aircraft where the hot zone is very near to the aircraft. In this class, I am going to discuss about different types of fire, how to prevent the fire, what type of extinguishers are used for prevention of this type of fire, and so many things I am going to discuss. More. Okay, hope it will be very useful for you all. You know, I am Dr. Yagya Dutta Dwivedhi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. These are the topics and the CO mapping. It is very much essential that the course outcome of this has to be matched with the requirement of our norms. So in this I am going to talk about nature of fire, classification of fire, principles of fire extinguishing, extinguishing agents, identification of fire extinguishers, fire detection systems, and these all are belongs to the course outcomes of 2. So these topics I am going to take in my next slides. So nature of the fire, we always talk about the fire triangle. So fire triangles, first it is fuel, we need some burning material, we need some oxygen, and we need some heat. If you mix this all the three things, then burning will take place here and explosion will start burning. Fire will take place. Burning or fire will take place. So this is called the fire triangle. So there are the 3 main elements or essentials needed for the fire. And if you know, if any one of these things are not there, fire will not take place. So as a fire engineer, we should understand that what we have to do, that fire is extinguished in a given time. First one is the fuel. So what is the fuel? It is a combustible gas, liquid or the solid. It may be cloth, it may be petrol, it may be the wood, it may be some leaf or anything. This is called the fuel, which is burning. Then to have this burning, we need some air or the oxygen. Oxygen is very much essential. So without oxygen, you cannot burn. If you have these both things, you need some temperature. That temperature only will make it to burn. Otherwise, you put the fuel and you put the oxygen, nothing will happen. To burn these two things, we need some amount of temperature. To bring fuel to its ignition point, we need some temperature. In that temperature only, your aircraft is, your system is start fire or burning. We can divide the fire into different categories. So there are 4 classes of the fires: class A, class B, class C, and the class D. So everyone, we have to understand what is the class A and what is the class B, what is the class C, and what is the class D. So class A is general items like paper, wood, textile, rubber, all the cloths. These all things comes under the class A. Class B means it is a liquid like petrol, diesel, such as gas, alcohol, oil and grease. They all comes under the class B. All liquid petroleum product like greases, gas, your alcohol, ethanol, methanol, these all things, oil, your engine oil, your gearbox oil, all the things comes under hydraulic fluid. This comes under the class B. Class C is electrical power, electrical fire, in which electric is used to give the fire, like short circuit and all. So it is a class C, electrical fire. Class D occur in a certain metal like magnesium, sodium and potassium, titanium or zirconium. This metal fire, class D is a metal fire. So we can divide into class A, class B, class C and class D. Class A is a general fire. Class B is a petroleum or the liquid fire. Class C is the electrical fire and class D is a metallic fire. So this is a general big way we have to, and here is the reference. This all taken from this reference. Principles of extinguishing fire. So how we can extinguish the fire? So I have just now told you a fire triangle. So first I need a fuel. Then I need a air, then I need a heat. These are the three components to get the fire. Okay, so how these things can be done? So, first thing is the heat. So if you can make some cooling effect, so it can be, fire can be extinguished. Then remove the air. Remove the O2 or air. If you remove or you protect that air is not entering, it will extinguish. Or separate the fuel. Remove the fuel. Remove the product like cloth, paper, wood, plastic, metallic, petrol, diesel. If it is there, you just try to remove it from there. So it will happen in this way. Okay, so this is the basic principle. So these are the, first is called the cooling. Then it is called the remove the oxygen and separate the fuel. So it is called starvation. Okay, so now I will discuss about the class A, how we can extinguish the class A fire. And you know that what is the meaning of class A? General fire. General fire by paper, wood, cloth, etc. So respond best to water or the water type which lower the fuel below its ignition. So how this thing use the water? Water. So you might have seen that our firefighting people, they have very good, very big truck. In that they have the pump. They will just very high pressure water they will do. Most of the time we have the class A type of fire. Class B fire is the petroleum product where your liquid, diesel, petrol, grease, hydraulic oil, these things are there, and in that if you use the water, it will not be effective. It will give a cooling, but your oil will be above the water, so it will be keep on burning. So it may not be able to sustain. So we need some chemicals. So to prevent the fire, of class B type of fire, we need some chemicals. So respond to carbon dioxide. So if we use the carbon dioxide, so we use the CO2 cylinders for this. Respond to carbon dioxide, halogenated hydrocarbons, it is called halogens, and dry chemicals, all of which displace the oxygen supply, making combustion impossible. So in this, what we'll do, just you see, it is a fuel here, it is a heat here, and here is the oxygen. So in this A class, we will remove this fuel. B class, what we will do? We will isolate this oxygen. first we have to isolate this oxygen. If the oxygen is not there, so we have to put some carbon dioxide. So this carbon dioxide will make sure that oxygen is not entering, air is not there, and it will be responded. And after that, you can use the heat. This you can put the water, so heat will be removed. If you talk about the class C fire, respond best to carbon dioxide, which displaces the oxygen. So in this also we use the CO2. So this CO2 will be, we use the CO2 in this electrical fire. This is what? Electrical fire. So carbon dioxide is the best method for this. So we will have the cylinder. In that cylinder, the carbon dioxide is put in a very high pressure, that is sprayed. Must have a non-metallic horn to prevent static electricity and transmission of electricity to operate from the fire. So if you want that carbon dioxide to be used, we should have some insulated material like rubber, plastics to hold, and then you spray. Otherwise, you will get the shock. So the operator has to ensure that the cylinder should have the plastic horn from where it will be sprayed. So that we have to take care of if you are handling the electric or the CO2 type of fire. Class C is, we use the halogens or the dry chemicals may be used, but the disadvantage is the powder contamination, which can lead to further damage of the electrical component. So if we use some dry chemicals or halon, these halogens may be affecting your electrical system. Insulations will be disturbed. So it is, try to avoid using other chemicals, but CO2 is the best way. But if it is not able to control, then you have to use this type of chemicals also. Class D responds to best to dry powder, which prevents oxidation and the resulting flame. So if it is a metallic fire, you have to use class D. So you have to use a dry powder, and it is a chemical, and this we have to spray there and try to deoxidize the system and try to avoid this, and in this way the fire can be extinguished. Now, how you are going to identify which type of fire is taking place and which type of extinguishers to be used. So if you are using a class A, a triangle containing the letter A. So if this is your cylinder, fire extinguisher, okay, this is the cylinder. So here you will get a triangle, a red color triangle like this. Triangle containing A. In this A will be mentioned, and the color will be green. So this will be a green in color. This triangle will be green in color and A will be mentioned. So you can identify by this. If it is a square containing the letter B and it is a red. So if it is the square, if it is a class B, then there will be a square like this. And it is in the red color and mention B. The same color what I am here, it will be mentioned B. If B is mentioned like this in a red box, this is the red box, like I am just making the same by my own hand. This is the B. It is mentioned in the red color. This you can see that it is a class B type. Okay. So a square containing the letter B in the red color. So if you want to see class C, circle containing the letter C. So in this, this is the extinguisher, and it is very thin type of black color. Here is the nozzle, and here the horn should be like this. A plastic horn is required, and here is the CO2. CO2 is fixed. There is some opening valves are here. So circle containing the letter C. So here is a circle and here will be the C, and the color is a blue, not red. It is a blue color. This circle and this C will be in the blue color. If it is like this, you can understand that this is the for the C type of fire. For the D type, it is an electrical fire. This is the metal fire. It is called the D fire. 5 points star containing the letter D, and it is in yellow. Just I will be writing here again. 5 star point, 1, 2, 3, 4 and 5. Like this, it will be mentioned here D, and the color is yellow. So this yellow color you have to use for the class D type of fire extinguisher. And in this you won't have like this. You won't have this. Only a small hose is here. This hose will have the spray like this. So it is for the class D type of fire extinguisher. Now, requirement of fire protection system. Oh, why we need this fire protection system? That we should have some reason. So, fire warning system must provide an immediate warning of fire or overheat by means of a red light and an audible signal in the flight deck. So, a red light should come and some beep should come, sound should come that there is a fire. The system must accurately indicate that a fire had been extinguished and indicate if the fire reignited. So there's some more system should be there. It should indicate that the fire is diminished or extinguished and indicated in the cockpit if the fire is again ignited. The system must be durable and resistant to damage from all the environmental factors that may exist in the location where it is installed. The system must include an accurate and effective method for testing to assure system integrity. The system must be easily inspected, removed and installed. So these points one by one I think we can discuss that. First of all, in this point, there should be a warning light, mostly red, with alarm beep in cockpit. That is the first thing. If you see about the second, the system must accurately indicate. The indication should not be false. Indication should not be false. Accurate indication. And if again ignited, if again fire taking place, should give alarm. Should give alarm. The system must be durable and resistant to damage from all the environmental factors. Okay, it should be robust in all conditions. Accurate and effective method. Accurate and effective methods to be used. Then easy to inspect. Easy to inspect. You have to design in such a way that very quick action can be taken. So these are things we have to ensure. The system and the component must be designed so the possibility of false indication is unlikely. No false signal, because it will cause a lot of panic and a lot of problem. The system must require a minimum of electrical power and must operate from an aircraft electric system. Minimum power required. Minimum power required to operate fire fighting system. These are the requirement for the any firefighting systems. Now I am going to discuss about fire detection system. First we have to detect. So if we are able to detect, then only the next step is the extinguishing. So how to take action and how we can extinguish the fire. So here we have the 4 type of systems. First is the thermoswitch. Then we have the thermocouples. Then we have the tubular type. In this we have the Fenway System and pneumatic type cistern donor. So first I will discuss about the thermoswitch. So what are the thermoswitch and how they are working? The thermal switch sometimes called a spot detector. So this is called a spot detector. Works by expansion of the outer casing in the unit. So what will happen? This will expand as the heat is there and it will make the switch to operate. When exposed to heat, the casing becomes longer and causing the two contact inside to meet, thus closing the circuit. Closing the circuit activated the warning system on the flight deck. So what is there? There is a one plate like this, another is very close like this. This is outside, and if here some heat is here, this will expand, and here are some switches like this, and this switch will be connected. This connection will make here one light is here and also one beep. The sound will also come, beep and light. Beep and the lights are there. These beeps and lights will work and they will produce the light and the sound. And also automated operations also can be done and the circuit will be completed. Closing the circuit activate the warnings system on the flight deck, and this is your cockpit. In front of the pilot, the light will burn and your beep sound will also come. So it is called the thermoswitch. Next is your thermocouple. We know what is a thermocouple. If two dissimilar metals are joined together, dissimilar metal, if they are joined together, they will produce some EMF. It is called the thermocouple. Okay, also called the rate of rise detection system. It is called rate of rise detection system. A circuit where one or more thermocouples are connected in series to activate an alarm when there is a sufficient temperature increase at the sensor. So if suppose here a normal temperature, and if other temperatures are there, it will generate the EMF, and here the bulb will illuminate and all actions will be taken. Thermocouples are made of two dissimilar metals which are twisted together inside an open frame. This is here twisted and made it open frame. The frame allows air to flow over the wires without exposing the wires to the damage. The exposed wires make the hot junction. The cold junction is located under the insulating material in the sensor unit. So it is a hot, and here is the cold junction, a separate. So when there is a difference in the temperature, a current is created about 4 milliampere. The current created sets off a sensitive relay, activated the alarm. So if the additional current is generated, it will sensitize the relay and the alarm will be rang. If the temperature rises below, so that the cold junction heats up along with the hot junction, then the relay will not be activated. So if the temperature rise is very slow, the cold junction again heat up along with the hot junction, and there will be equalize and the system will be cut off. Next is the Fenway system. This is another type of detection system. It is called the Fenway. It is a continuous loop system. Consists of a small, lightweight, flexible, inconel tube with a pure nickel conductor wire center conductor. The space between the nickel conductor and the tubing wall is filled with porous aluminum oxide, ceramic insulating the material. Any void or the clearance are saturated with a eutectic salt mixture which has a low melting point. The tube is hermetically sealed at both ends with insulating material and threading fittings. When heated sufficiently, current can flow between the center wire and the tube wall because the eutectic salt melts and the resistance drop rapidly. Okay, so in this what happened? There is a flexible tube inside it is a inconel filled with a porous aluminum oxide. Here we have the aluminum oxide inside, and here is a ceramic material. So when it is heated due to fire, so the current is generated. Current can flow between the center wire and the tube. So this wire and this is the tube. So between this and this, current will be flowing and the resistance drop, and the resistance of this thing is dropped sufficiently okay. So the increased current flow provides a signal which is used to in the control unit to sound the alarm. So as the current is produced, it provides a signal and a alarm will be sounded. Once the fire is extinguished or the overheat condition is corrected, the eutectic salt increases its resistance and the system will return to a standby mode. And so if the fire is extinguished and temperature is lowered, it will be again reaching to its original position, original equilibrium condition, and stand by for the next operation. So this is the Fenway type of it is somewhat more modern system of operation. Next is Kide system. So in this also, if you see here that it is also a same type, it is a continuous loop system. Utilizes an inconel tube with transmitter material embedded with two electrical conductors. Here some other materials are used. In previously some other materials was used. One conductor is grounded to the outer shell at the end of the tube. So one is grounded with outer shell. When heated, the transmitter material drops its resistance. The change in resistance is sensed by the electrical control unit monitoring the system and sends a warning signal to illuminate the fire warning light and activate the oral warning device. When the condition is corrected to the system, return to standby mode. So it is same way the functioning, only the material is here we use the transmitter here transmittal material. So as the heat is increased, the resistance of this thing is dropped, and this is sensed by the electrical control unit, and this will give signal to the required system. The sensing element in the relay system is unique because it consists of two wires conductor. So in this, two wires are here. That is the uniqueness. The wire conductors are of two different circuits and allow for complete system redundancy. So it is very effective, most reliable system, as it is using two wires. If one gets false, another will correct it. The control unit is a transistorized electronic devices, consist of two component board assembly, a test switch, test jacket, wiring harnesses, and an electrical receptacle, all indoors in a metal case. So these all all the things are in the metal case, and this all items are procured in this system. Next is the pneumatic system. Means some air is there and it is called cistern donor. The name of this system is a cistern donor. It is a continuous length system. It is all over, it is covering. The sensing element consists of a stainless steel tube containing two separate gases plus a gas absorption material in the form of wire inside the tube. Normally the tube is filled with helium gas under pressure. The titanium center wire, which is the gas absorption material, contains hydrogen gas. The wire is wrapped in a helical fashion with an inert metal tape for stabilization and the protection. Gaps between the turns of the tape allows for rapid release of the hydrogen gas from the wire when the temperature reaches the required level. So just it is a continuous length system. So here we have the stainless steel tube, SS tube. It is the SS tube. Containing two separate gases, absorption material in the form of a wire inside the tube. So here we have the two wires. These are the two wires. Normally the tube is filled with the helium gas. So here we have the helium. This is the He, helium. The titanium center wire, which is the gas absorption material, contains hydrogen gas. So this is the titanium. It has got the hydrogen gas. The wire is wrapped in a helical fashion with inert metal tape for stabilization and protection. So it is wrapped like this helical. Gas between the turns tape allows for the rapid release of the hydrogen gas from the wire when the temperature is increased. When the temperature is increased, this will increase the hydrogen gas. It will release the hydrogen gas from the wire. The temperature reaches the required and a signal will be a bulb, and the signal bulb will be given, and the beep is also coming. Now I will talk about the fire extinguishing agent. What are the materials which are used to extinguish the fire? So agent work by the two methods. First is displacing the oxygen, remove the oxygen, chemically combined with oxygen to prevent combustion or to prevent the combustion. You remove the oxygen or you convert this oxygen to another type of gas which is not burning. Agent commonly used are carbon dioxide, freon, this is a chlorinated hydrocarbon, then halon 1301, monobromidic ethane CS3Br, and the nitrogen. CO2 is usually limited to the older type of systems. Reciprocating engines powered aircraft we use. Freon is used in modern aircraft. Halon 1301 is used in modern aircraft. N2 is typically used primarily in current system as a propellant for the other chemicals. So CO2, freon, halon, and the nitrogen, these are the used. CO2 is used for the old type of aircraft because it is not good for health, and it is used for the reciprocating powered engine. Freon is used for modern aircraft. The halon 1301 is also used for the modern aircraft. N2 is typically, this nitrogen is typically used for primarily in current system as a propellant for the other chemicals. So fire extinguishing agent, liquid freon and halon 1301 are stored under pressure in liquid form, but when released are in gaseous form. So this liquid freon and in the liquid form, but as and when it is released, it becomes the gas. When released, the gas can cause frostbite due to the extreme low temperature during the. So we have to take very much cautious. It should not touch by hand. Dry chemical extinguishers are not used because of the damage caused by the toxic and the corrosive chemicals. We are not supposed to use the dry chemicals on aircraft. Some gaseous agents may be considered toxic because of the rapid displacement of oxygen when used. So these are the few disadvantages of the system. So fire extinguishing systems, we have the conventional systems and the high rate discharge systems. HRD means high rate discharge system. It's called HRD systems. So the conventional used on older reciprocating aircraft usually utilizes the carbon dioxide. High rate of discharge HRD systems used widely and more efficient than the conventional systems. Utilizes freon or the halon 1301. Used nitrogen to propel the extinguishing agent at higher speed. So conventional systems uses a perforated ring and distributor nozzle discharge arrangement. When activated, the carbon monoxide bottles are opened and the gas flows through the lines to the selected engines. At the engine, the gas flows out of the perforated ring and distributor nozzles to smoother the fire. HRD systems are used for most of the modern aircraft. Utilizes spherical bottles under the high pressure actuated by explosive charges to flood the compartment and displace the oxygen. Operation: fire switch closed by crew members in the area where a fire is indicated. Explosive charge at the neck of the bottle is detonated and a cutter is driven through the sealing disc in the neck of the container. This instantly releases the extinguishing agent to the area selected. Now, thermal discharge. Bottles in the conventional and the HRD system utilizes pressure relief fitting for discharge in high heat or the pressure situation. Two methods used to determine thermal discharge. Gauge on bottle visible through windows on the outside of the aircraft. Red blowout disc, a small pressure line is run to an open area like a wheel well, and when a thermal discharge occurs, pressure in the line will blow the disc. In a regular discharge situation, either a gauge can be read or a yellow blowout will be missing. These are the references which I have used: aircraft power plant PP 649 and aircraft maintenance and the repair PP 602 614. Another book is Moir I and the Seabreeze A. Design and Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. Any questions you can ask me in my this email, ydwivedi@gmail.com. Okay, so please like and subscribe this channel. If any query you are asked, you are welcome to ask. Thank you very much for listening. Be tuned for my next lecture, and next lecture is also going to be very interesting for a new topic on aircraft system. Thank you very much for this lecture.
Like, share and subscribe. Hit the bell icon for more updates.